Hey, hi, hello, vanakkam. This is our eighth video of top 100 lead code lecture questions, and today we are going to see number 239 sliding window maximum. Comes under hard category, but really it would be very easy to solve. And we are currently working on sliding window programs, and this also comes under sliding window. Okay. In this case, we are going to see. I'm just moving it down. Okay, and today we are going to see sliding window maximum. This question description is: you are given an array of integers nums. There are sliding window of size k, which is moving from the very left of the array to the very right. You can only see k numbers in the window. Okay, each time the sliding window moves right by one position, uh, you should remove the very left portion. Okay, you should contain only k elements inside that. Return the maximum window, return the maximum sliding window. Okay, for an example, here they would give the input as nums and k is 3 here, and we have a array of nums, and we need to give output as an array. And here is the explanation. I will explain it on analysis page. Here I'm just giving overview of it. uh, Here they have mentioned k3, so you need to take three elements in a window and take the maximum and put it in the return output window. Okay, and you take the next three category and take the maximum one and return it there, and take the next window, next three elements, and take the maximum and put it in the array. Same like that, you should keep it until the array ends. Okay, it's very easy. We'll start with the analysis. So we came to the whiteboard, and we have a problem here, and we have a k3. In this case, k3 is 3. So once we reached our three elements, then we can write our uh, result. So for the result, I'm just opening one empty array. Okay, now here I'm going to have my p1 and my p2 is here. My p2 points to 0, so I'm going to use a dq in this problem. So in my dq, I'm just storing my index only, not the value. I'm just going to store index. I've stored it 0, and I've stored it. Now I'm moving this p2 pointer one step forward. Now I'm checking that p2 is points to 3 as a value, and index is 1, correct? But I need to check one thing. I need to verify one thing, which is this index shouldn't be crossed this k3. Okay, so the formula is current index is 1, current index is 1, and once we reached k minus 1, then we need to remove the first element. Okay, because we are going out of the window, right? So we need to remove the first element. So in this case, my index is 1, and k is 3 minus 1 will be 2, so it's still below. So I don't need to change anything, I don't need to remove anything, I can just append here. But in this case, um, my first value is 0, sorry, first index is 0, value is 1. This value is smaller than my current value, correct? This dq's first value is smaller than current pointing value, correct? So I'm removing this value and storing the index, which is bigger right now. 3 is bigger. Okay, now I'm checking again to store the result set, these windows should be reached. Otherwise, we don't need to store here, right? So I'm just ignoring and okay. Now we moved our P2 to the -1. It points to -1 and the index is 2. I'm checking. I'm comparing with the current value and my DQ's first value. My DQ's first value is 3 and my current pointing value is -1. So we don't need to store. Instead, I can just append this -1 after this 1. Okay. Once I have done this, then we need to check one thing, right? Like 2. My current value is 2, my current index is 2, and k is 3 minus 1 is 2. It matches, correct? If it matches, then we can store the value, we can store the uh, maximum value to the result set. Here I know that my DQ's first value is the maximum. My DQ's first value is 1. So sorry, first index is 1. So this index points to 3. So I can store the 3 in my result set. Now I'm moving P1 forward because it reached already, right? So I'm moving this P1. When I stored the result set, then we can move the P1. I've moved it, and meanwhile I'm moving P2 as well. My P2's value is -3. I'm checking the index first. This index is 3 and my first index of DQ is 1. So here it is 3. Actually here I need to check P2 minus P1. P2 is 3 and P1 is 1. So it's 2 and here also 2. So it can stay. P1 can stay there. We don't need to remove anything, any value from the DQ. So now checking the current value and my DQ's first value. My DQ's first value is bigger than the current value. So I'm storing the value to the result set. Now I'm moving the P1 forward. Meanwhile, P2 as well. Once I moved, I need to check my P2 is from the 2, right? But DQ starts from 1, but it's not in the window, it's out of the window, right? So we need to remove this window. Okay, I removed it. Now I need to store the P2. P2 is 4. My DQ's first value points to -1, but current value is 5. So current value is the bigger one. So I can store current value to the DQ, not the value, it index. Okay, I have stored the 4 here. Once it's stored, I need to check that 4 and my P1 stands at 2. It matches, right? So if it matches, then we can store the result set. My my current maximum value is 5. So I can store the value. Then I can move my P1 pointer one step forward and P2 pointer as well. Once I moved, I'm checking my P1 pointer. P1 pointer is 3 and my DQ's current index is 4. So it maximum, so no problem, just keep it. And my P2 current value is 5, but my current DQ's value is more than that, 5 actually. So you can just keep it, no need to change. And I'm checking with my formula. Currently staying at 5 and P1's index is 3 it's still 2, so we can store the maximum value to our index result set. So I'm storing 5 here, and meanwhile I'm moving this p1 and p2 also. When I move the p2 and p1 points to fourth index is in my DQ, so it's in the window, so that's not a problem, it can stay. And sixth element points to sixth value, has a sixth value, then we can replace it, right? Because it currently points to 5, my DQ's value points to 5, but current P2's value is more than that, then I can change the value 6. Once I changed, I'm checking with my formula, it is 6 and here it is 4, it's 2, it matches, then I can store the value to the 6 to the result set. Meanwhile, we can move the p1 pointer and p2 pointer also to further. Once I stored, I'm checking my p1's current index is 5, is lesser than dq's first value, right? Dq's first index, so sorry, its value. So 5 and 6, so 5 is smaller than the 6, so it can stay. And p2's value is 7, so 7 is bigger than 6, so I can change the index 7. And I'm checking the index with the formula points to 7 and 5, it matches to 2, and I'm storing the value which is currently present in DQ 7. So this is the answer. 335567 is our answer, so it works. This is the same kind of procedure, right, which we followed last some problems. And there's a brute force approach also, you can try that. In brute force approach you can do like we know, right, how many are in the window. So 3 are going to be in the window, so each time you're going to choose the bigger element, right? But this case you would end up with order of n cross k as a time complexity, but in our case we can do it with order of n time complexity. This is very much efficient because we are using DQ and we are just storing whatever value we wanted, and we are removing the extra window elements, and finally we can give the result as a array. That's it. We came to the code, and here is my Python code. Here I have a method, and this method it starts with the empty check. Okay, if suppose we don't have any slide, we don't need any window, if it is 0 or my input value is empty, then I can return a empty array. Okay, so this check is must for some cases, and I'm initiating my result, and DQ you need to import it for Python from collections, and I have a p1 and a p2 as my pointers. In while I'm checking p2 shouldn't exceed my current numbers input. Okay, so then I have one more while loop. This while loop checks that DQ is empty, DQ is present or not. If DQ is present with some values, then I'm taking the first element. Yeah, I'm taking the first element, and I'm checking with my current p2. Okay, first means left side first. Okay, I'm checking the value, and if it is smaller than that, then I'm popping the value, and okay, until it gets bigger value. it's to until it finds a bigger value, or until it's get empty. Okay, and I'm storing a value. I'm just appending a value with p2, and then I'm checking if condition checks that dq's first index and p1's value. If p1 is p1's index, if p1 index is greater than dq's first element, then I'm just popping it. Okay, because if it goes out of the window, then we need to remove it, right? So, and this is a if condition. This if condition checks that with our formula, p2 plus 1 and k. If it equals to that, then I can store the result to the our result set, and I'm just incrementing p1 and incrementing p2 out of the if condition. Then finally we can return the value. Okay, I'm just running it in debug mode. Okay, it runs now, and first all are got get initiated, and while loop starts, p2 is currently 0 and p1 is 0, and my k is 0, k is 3, and the result is empty array. First of all, dq is empty, so we don't go inside, and dq is going to append with p2's value. p2 is, yeah, 0th index. We are just storing index only, not the value. And I'm checking with the if condition. This if condition checks that p2 plus 1, and if it matches with k, if it matches with kth index, then we can store the value to the result. Still p2 is getting incremented, and now dq is going to append dq p2's index. P2 is the index, and it stores the value next to the our previous value in dq. And when I'm checking this, p2 is already reached, right? So it can store the value to the result set. It stored 3 here, and p1 is getting incremented, and p2 also getting incremented. Now it can go in a flow, and dq is appended, and if value is out of the window, then we remove it, otherwise not required. And here we just appending the value, appending the result set. So here I'm popping it because it's already my current value is 5. Okay, my current value is 5, but my dq contains first value as 3. Okay, so I just need to update it. So I'm popping everything, and I'm storing fifth values index. Once it's stored, and I'm appending value to the result set, and it's go in a flow again. It store the value as a 5, and we found a 6, so we need to remove the index 4 and 5. Once we removed, and we append the sixth index to the dq, and storing the value to the result. And again same, we found a 7, so we just removing and appending the value to the result set. Finally we return the result. we got the we got our answer. Okay, it's accepted. Now I'm submitting it. Okay, it's accepted. It's working. So we'll check the time and space complexity for it. It it takes order of n time complexity, because we are just um, iterating through our input array only once. So it's just order of n time complexity. And space complexity wise, it takes we need to give it as a result, right? So and we are storing tq, so we can consider this as a order of n plus k, because we need to return the result. And we're going to return a q. uh, we're not going to return, we're just going to write it. dq at least going to contain one element to till k. Okay, that's it. Okay, that's it for this problem, and I'll post this problem on GitHub repository and share the link and problem link as well. Thank you.